Welcome to Study Loop.
Okay, so we have a 20-meter wire, which is attached to a fixed support at A, and at B, it is attached to a collar. This collar can move freely in the X direction, but it is fixed in the Y direction. We will neglect all friction between the collar and the rod holding it. The mass per unit length is 0.2 kilograms per meter. The span, L, is equal to 15 meters. And as I said at the beginning, the total length on the wire, SAB, is equal to 20 meters. So one of the first things that we need to do is, well, first of all, the question is we need to find the sag H and we need to find the force P. So the first thing to do in solving this is we need to find X and we need to find S. So S is simply half of SAB, which is equal to 10 meters. And then X is equal to L over 2. It's just half of L, which is equal to 7.5 meters. So now we need to find C. Using our equation, S is equal to C times hyperbolic sine of X over C. Plugging in what we know, we get 10 is equal to C times hyperbolic sine of 7.5 over C. Solving for this equation, we find that C is equal to 5.55 meters. Now that we know the value for C, we can use this to find Y. Y is the distance between, Y is H plus C. So Y is equal to C times hyperbolic cosine of X over C. Plugging in what we know, we get Y is equal to 5.55 times hyperbolic cosine of H times 7.5 for X over 5.55. Solving this equation, we get Y is equal to 11.437 meters. As I stated earlier, Y is equal to H plus C. So now we have Y, and now we have C, so we need to plug it in and find H. So 11.437 meters is equal to H plus 5.55 meters. So we find that H, which is the sag, is equal to 5.887 meters. Now we need to find the force P required in order to we need to find the force P required for when the span is 15 meters. In order to do that, we need to look at point B. And we know that P, because B is holding steady, we know that P is going to be equal to the horizontal factor of our tension. So in order to find T naught here, P is equal to the horizontal tension, which we know is equal to our mass per unit length times C. But we want P to be in newtons. So we need to take so what we need to do is we need to multiply it times the gravitational acceleration of Earth, which is 9.81 meters per second squared. So we plug in what we know. P is equal to 0.2 kilogram per meter times 5.55 meters times 9.81 meters per second squared. And we find that P is equal to 10.9 newtons.